Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? Today's video, I wanted to talk about the wave swinger.
Now get ready. Here we go.
And one of the reasons for this video is because there was an accident that came up recently, basically at Waldameer Park in Erie, Pennsylvania. I wanted to go over this, and I wanted to do basically a reaction video for this, but it turns out that I started thinking about it and I said, well, I'd have to explain it like this and I'd have to say this and do that. And there really wasn't a good way to do this without explaining how the majority of the ride works. And I know it's been on my list of actually things to do. People have asked, they said, you guys have wanted an explanation of how a wave swinger style ride works. So I was like, okay, let's talk about the wave swinger then. So let's set the scene and figure this out, right? All right, so here it is. It's like 8 o'clock at night, right? It's after dinner. It's nice and warm outside. There's a slight breeze. It's really quite nice out there. We've done my workout for the evening. Come in here. I've got everything ready to film. I've had some Olive Garden that kind of had some dodgy looking shrimp inside of it. I'm not sure if that's going to shorten the length of this film or not, but I think it'll be okay. Wife's outside watching TV. Everything's going fine, right? What does that have to do with the wave swinger? Nothing really. Kind of off topic there. Sorry. Bringing it back to wave swinger. All right, so of the wave swinger style ride, these rides, you've seen them before. They're at carnival rides. They're at permanent parks. You'll see them all over the place. They all look the same from the outside. Now, there's tons of manufacturers that build these things, and they all look very similar. I mean, how many different ways can you build a swing ride? Because that's what these are. Well, realistically, we're going to be talking today about two rides, and there's not really much differences between them. The basic theory that I'm going to go over and talk about is essentially, it's just that. It's the basics. It's the stuff you need to know. How they arrive there is a little bit different for each one, but no, the theory that I'm talking about is fundamentally the same in the middle. So we'll start off with Zamperla. Zamperla makes a wave swinger. The trade name for this is actually called flying carousel. So Zamperla makes a flying carousel. If you look in their arsenal, they'll have a ride called the flying carousel. And a lot of parks actually call it a wave swinger. Kind of funny because the other manufacturer that builds the most of them out there is actually Zierer. And Zierer makes a trade name wave swinger. That's the trade name of the ride, is the wave swinger. Fun fact, the wave swingers that are out there made by Zierer, some of them are called flying carousels. So I thought that was interesting. Each manufacturer has stuff installed at a park or at a carnival, maybe wherever it may be. And some call them wave swingers, some call them flying carousels. They're all out there though. But that's the trade name stuff. There's also, like I said, there's also other manufacturers, but not as many as Zamperla and Zierer. So the basic of it is that it seems to be a lot of the Zierer models, although they sell them in parks, a lot of the Zierer models end up being traveling. So if you go to a fair, something that's traveling around, and you see a big swing ride sitting there, that's probably a Zierer model. Zamperla seems to make more of the stationary, but they also sell a traveling version of this. So, 50-50. Take it with what you can out there, but you can't really identify them unless you're walking around the center column. A lot of time on the fiberglass back of the operator panel where the operator stands, you'll see the name tag or the display tag on there that might say Zierer or Zamperla, depending on which model you're looking at. One way to identify them. All right, so let's talk about the breakdown at Waldameer Park in Pennsylvania. Okay, so this is right out of their, basically they did a press release that says Waldameer and Waterworld. And this happened, start reading it, this happened on the evening of August 17th, 2024. There was an incident at our Flying Swings attraction. Our medical staff and local first responders immediately assisted guests involved. We are investigating the incident, which includes a thorough inspection of the attraction. Flying Swings will remain closed until all investigations are completed and we can ensure safe operation. Safety is our priority and our primary concern at this time for those affected by this incident. Okay, all right. So that was the official released by the park. I was surfing around a little bit looking for stuff. I came across this on Reddit. So not sure of the source of this one. Take it with a grain of salt, but I mean, just sounds credible. But there's really nothing here. It's just a more in-depth explanation of someone's point of view of what happened to the ride. So we'll go over this. Waldameer accident. This was at no fault of the ride operator. That's an interesting statement right there. No fault of the ride operator. So this person basically feels ride operator didn't do anything. This was a freak accident that could have been avoided if an older child wouldn't have been messing around and kept his lap bar down. This caused the malfunction. Okay, we're not assigning blame. We're not going to do any of that stuff. We're just moving on. My daughter and I were on the Flying Swings when it happened, and it was the Flying Swings that had the accident. An older boy had unlocked his lap bar and was lifting it up when we were in the air. The operator was warning him several times that he didn't do it, so he said he was stopping the ride and bringing it down. The ride went down, but it kept spinning at full speed. As soon as the swing started hitting the umbrella at the operator station, we knew we were in trouble. The ride didn't even load down until the swing started hitting... Oh, must be slow down. The rides didn't even start slowing down until the swing started hitting the railing. Can't fault people for grammar. I'm horrible at it myself. Multiple people, mostly children, were injured. You could tell 3 of them had broken bones and one had a gash on his foot. I tried to reach the boy that had the gash, but he was too far and I couldn't reach him, couldn't reach anyone behind me. I was also trying to keep my daughter safe at the same time. She was on the outside part of the swing. I'm now wishing she would have been on the inside part. She would have been safer. Okay. Once the ride finally stopped, I froze in shock for a minute. It took me to comprehend what had just happened. And then the rest from there is basically just going on the detail of the scene, screaming, panic, that sort of stuff. So it's not going to be useful to me to read on for that. Okay, so that's the accident. So that's what I wanted to talk about. But again, to talk about how a ride might have malfunctioned like that means I had to get pretty deep into how the ride functions, and I couldn't do that on a simple reaction video that I normally pop up and make. Normally I would have made this like on Monday or Tuesday night and put it out the next day. That way I had that, but I feel like this needed more of an in-depth explanation of what I can figure out with this event. So we're just going to go into the generalistics of how a wave swinger operates. Now I'm going to go over basically the parts that make up the swing, and I'm not sure if I could find pictures and stuff for this stuff. There is not a lot out there. I'm sure once people see this video, they'll be like, oh yeah, here's some videos that you could find. But basically, this is something like the best part to see this stuff would be if you were up close and personal for the setup of the ride, like at a fair or something like that. And I know there are a couple of time-lapse videos real quick that show these rides being set up. I've got pictures from a couple of those, but they're hard to really see down on the inside of what's there. So some of this is just going to be kind of vague and visual. So we're going to start with the lower frame. This is the part that on the traveling rides is bolted to the coach or the trailer. And on a permanent ride, this is bolted to the concrete. The lower slip ring sits in the center, and it transmits data and all sorts of other information across there. And the lower speed controller, which is a proximity sensor that sits on the side, because on the side of that there is the lower motor and brake, and the lower hydraulic coupling. So the hydraulic coupling sits in the middle of the slip ring stack at the very bottom to transmit hydraulic pressure up to the tower. Both the Zamperla model and the Zierer model have to have hydraulic pressure going up. Two different reasons. Get into that in just a minute. But also at the same time, that all rests at the very base on the bottom of it, and then on top of that is a slewing ring. A slewing ring, it's a geared slewing ring that is what transmits the motion from that lower motor into the center. So the center of the ride, which supports the weight, it's a big tall column. That tall column is actually called the tree. Well, it is on the Zamperla model. They call it the tree. The tree is the part that the whole canopy rides up and down on. So in the tree, there are limit switches going up the tree that tell the ride where that canopy is. All those limit switches are communicated through the bottom, through that slip ring stack, and out back to the ride control system. The hydraulic lifting cylinders are next. Now there's two different types of methods that happen here. The first one that I'm most familiar with, I've worked a lot on the Zamperla model, and what they use is two hydraulic cylinders off to the side of the tree, one on each side of it, and basically they are attached to the center hub. I'm not sure what the name is on the Zamperla one. On the Zierer one, I was able to find out that that hub piece in the center, they call that a basket. Don't know if the same terminology on the Zamperla model, but Zierer, it's the basket. I'm not sure what it's called on the Zamperla model. But anyways, the hydraulic cylinders are mounted to that hub, that basket in the center, and then they push off of the bottom. And then it's those hydraulic cylinders lifting up, which raise the entire canopy up. Those hydraulic lifting cylinders on there to the basket. Now, the Zierer model uses a tube in the tree. The Zamperla model uses, basically, it looks like an I-beam. If you can imagine that, it's got a center plate and two plates off to the side. And that allows wheels to stay in the center track and also guide it at the same time as it goes up and down that center tree. The Zierer model uses a big tube going up there because they actually put their hydraulic cylinder in the center of the tube. But what they do is they use a set of cables that come up and out over the top of the tube and then come back down and attach to the basket. I've never worked on a Zierer model, but I have their service bulletins. So I was like, oh, that's how Zierer does it, because there's service bulletins out there about how the lifting assembly attaches with the cables and reattaches back to the outside. So great sources of information if you know what you're looking for and what to look at. So not anyone can find these service bulletins if you know where they are, what to look for. On that basket that everything is riding on, there is another external geared slewing ring underneath that. That slewing ring is for the upper motor. You have a lower motor on these rides and an upper motor. The upper motor has the same stuff. It's a big, again, Zamperla, it's a DC motor, top and bottom. They're big, they're heavy duty. They have a electromechanical brake off to the side. That means it needs power to release the brake. And then when you take the power away from the coil, springs push the pressure plate back down and it applies the brake. So the lower and the upper have a brake. The lower and the upper are DC. On the Zierer models, those are hydraulic driven. So where you'd have hydraulic feeding the canopy up there, you would have the second set of slip rings from, or hydraulic slip coupler to go from the lifting mechanism to the actual motor itself to power the rotation of the motor. Honestly, the hydraulics are more of a pain to keep sealed. They leak, they do all sorts of stuff. But hindsight looking at it, I'm sure I will get people that have worked intimately with the wave swinger models from Zierer. Looking at it, it's like, oh man, I bet the hydraulic drive system has a lot less gremlins in it than the DC drive systems did, because those were a giant pain in the butt to keep synchronized and running smooth. Ooh, That was nasty. So it has a slewing ring down there. It also has a safety sensor on the side, which counts the teeth as it rotates, using that for speed feedback on there. And then the basket comes up, and then from the basket, or that center hub, that's where all the spokes for the canopy start to attach. The spokes are big metal arms that stick out. That's like a trellis style arm that sticks out there. And then they go out there, and then from the top of that arm back, there's typically either a supporting cable or a supporting rod that helps that arm stay nice and solid out there at the end, because most of those rods are either holding two or one person on there, one person or two people on there. So they need to have the weight and loading as far out as possible. So you want to support it all back to the center. And those rods and cables are tensioned and tightened to take the stress back to that center point as well. In the center, when I was talking about the geared slewing ring and the motor and all that stuff, at the top there is another set of slip rings, but this is a different set than the bottom because these are very big. It goes all the way around the basket, and that is simply to transmit the power to the lighting package. Remember, a lot of these showed up in midways, they showed up in traveling fairs, all sorts of stuff like that. So there is a lot of lighting that goes on to these things because you want them to look really good. And they do. They look amazing when they're all lit up at nighttime and all the light sequencers are causing them to blink, and they look great. So, but lighting is quite also a big pain in the butt on that, especially if yours isn't taken apart regularly. The Zierers, I understand they're torn down and pretty much taken down annually. The Zamperla models, like ones I worked on, most parks opted not to take those down because they were anchored to the ground. They were permanently installed. So a lot of parks I worked with, they did not take theirs down. They simply just left them in place. So what that does is for parks like mine that had a permanent install, that takes your electrical connections and stuff like that between the panels, and those start to go bad after a while. And now where a normal ride that gets torn down all the time and put back together, you would simply just take those plugs on the end and go through real quick when you had the panels off, just undo the plug, grab a new one, put it on there. And when I say plug, these things have like 20 to 30 wires on the inside. So they're big, heavy-duty plugs. They're not like something you could buy at the hardware store. Also very expensive, like a couple $100 per connector per side. But you would just take those off and redo them and then put them back together the next time they're up there, and you're done. Well, with permanent parks, you typically tend not to do that stuff because you're not taking the paneling off all the time. So there's much more static inspections and things like that that happen with them. So when those plugs start to go bad, you end up going up there and simply just taking the plug out of the loop altogether and just hardwiring the connections back. Well, that's going to suck the next time you have to take that panel off, but honestly, for the permanent runs, there's not that much reason to take the panel off all the time. And if you do, then you can always just cut them and then resplice them afterwards. You're probably going to need some new cable after a while anyway. But if it's a common thing where you're taking the panel off and on again, then the option would simply just be to put the actual metal plug back together. Okay, so we put the canopy on the outside, we put all the fiberglass on, and then up at the very top there's a big tent-looking device that's up there. And that is typically just heavy-duty vinyl. That's all that is. It is tent tarping material, like you would see anything that pops up where people are, maybe it's a sales tent or something like that. That big, thick, heavy-duty vinyl, that's what that upper top canopy is made out of. And realistically, that's just a looks thing. It just covers up everything on the center. When it rains, it tries to keep most of the water off of the inside of that stuff. So it's no big deal there. It's almost strictly just a visual thing, but it does help out keep the elements out of there and keep things like birds and stuff like that from nesting in the machine as well. Underneath the canopy, we're going to talk about seat attachment. The seat attachment underneath the canopy is to those big metal arms, those metal spars that I was talking about on the inside. And there are special tabs that are welded on where the seat eyelets come up and they hook on. The type of eyelet that's used to anchor the seat to the canopy is different depending on the ride. It's also depending on the year that it was manufactured. I've seen Zamperla and Zierers both go different directions with these for the same model. I've seen them with a big S hook. It looks like a giant S. It's a metal S. And they would put the top in and then just simply hang the bottom. And that's all it was. The top and the bottom have bronze bushings pushed into them so that that bronze wears instead of the metal S hook. I've also seen the same exact thing done with eyelets, where it's eye to eye on both sides with a metal rod in between the two. Nothing's adjustable, it's just the way it's shaped. So two big eyes like that, and they would sit top to bottom with the bar connecting it. Same deal. Those guys are permanent. They're NDT'd every once in a while. So you need to make sure that they're not wearing. The big thing with swing rides is wear. They do a lot of wear and tear on everything that's moving underneath that canopy. Everything is wearing down quickly. So that's the name of the game for all the inspections, is to check the wear and tear on that stuff. Typically after that eyelet or S-hook, whichever way it may be, you come down to what's typically referred to as a spreader bar. The spreader bar takes your single point from that eyelet or S-hook and then pushes 2 points further out to the side. Those 2 points are where all of your seat swing chains attach. So for each seat, and like a lot of these models, they use 48 seats, each seat has 4 chains that hold it. 1, 2, 3, 4. 2 in the front, basically where my knees are, and then 2 in the back, basically behind where my hips are, kind of in that general area they come up. You'll see them all the time that these seat chains, as they go down, they have plastic tubes over them, and that is mainly so people don't get their fingers pinched on the chain right there. There's a plus and minus to that on both sides. One way is that it's nice and smooth. You don't have to worry about people getting their fingers pinched. The other way is that every day you have to take those plastic tubes and lift them up to inspect the chain that's underneath there. So that's a lot of added time to the PM. I mean, kind of just depends on the area. I've seen tons of places operate with the chains with no tubes on them. Who knows if they ever have troubles, but I don't think anyone ever has troubles with them. They also make the same assemblies with cables, steel cables, so you don't even have the chain there. It's simply just cable. The only thing is they're much more expensive, and you typically can't make the cables. They have to be purchased from Zamperla or Zierer, which is not a problem, but a lot of parks want the ability to at least make their own stuff. The swing carousel that I was working with, we rechained that thing twice while I was working there. The chains don't wear out that often, but they do wear. So we rechained it twice, and both times we just obtained our own chain and did it ourselves. Now, it wasn't just like we went to the hardware store and found something that kind of looked like, yeah, that looks good. Let's put that in the ride now. We had documentation and we had engineering sitting there, and we knew what chain to use. It wasn't just a guess. So we would use the proper chain that was already spec'd out with engineering's approval to put it back on the ride to make sure it was going to be just as safe as it was before. Now, when we're talking about chain wear, say how do chains wear? Well, you have a link and a link, right? You put the two together. Well, right where the two come together, right there, right where my thumbs are touching right there, that's where the wear is. They will sit there and basically at a very small level, they will sit there and do this in every direction. And right where my fingers are touching, all in the center right there, that's where the wear is. So the only way to check it is to physically take the chain, take the slack off of it, and then move it like that. And then you're looking at the wear that would be right on the inside where those links were just touching. So it's actually a really simple thing. And now it always presents itself in the same fashion too. It's quite amazing. Out of all the links that are on that chain going all the way down, all the wear happens right at the seat attachment, right where that last chain link attaches to the seat itself. That's where the wear is. Every time. Every time we've gone through rechaining the swings, the ones that were getting close on their wear dimension, which was the diameter of the chain minus 10%, I believe it was. That was the maximum allowable wear for the chain. Anytime they were getting close to those dimensions, it was always the front two attachment points on the swing, not the back two. The back two looked like brand new. It was the front two that were always worn down. And the further out in the swing you got, the more they were worn down. So if we wanted to, we could have like done chain replacements and odds and ends of like, oh, this one, now that one, now that one. We never opted to do that. So we always just said, okay, once we got some that were getting close to their critical wear limit, we just did the entire ride. We're going to do everything. We're doing the whole thing. Okay. We just ordered tons of chain and got it in there and started cutting everything to length. We did a couple swings to make sure we had our measurements right. And then we just set it up like a production line and start cranking out chains. And then mechanics would go over there and start taking new chains up, getting up there, replacing the bushings on the hangers up there, pulling them back down. So chain wear is a big one. Some of these rides have a second chain on the front because the front is where all that wear is. So some of them have a second chain that actually goes out there. That smaller chain is actually attached to the main chain just about 2 feet off the seat. So as it comes up, 2 feet, click, it comes back in and connects right there. So you would say like, well, what good is that if that primary chain breaks? Well, all the history we have on them shows that if the chain were to break, it were to break right at that seat attachment point down at the bottom, and that safety chain would work. Are there rides out there without safety chains? Yes, there are. From the manufacturer? From the manufacturer that way. It's not a big deal. They're not worried about it. Okay, so if they're not worried about it, we shouldn't be worried about it either. Ours had safety chains. Maybe we were just being cautious. I'm not sure on that one. Maybe some of you can weigh in that have worked on these wave swingers, Zierers, Zamperla, it doesn't matter. Let me know if you had safety chains on yours, if it was something that was a good idea, bad idea. Kind of clogs up the daily inspection because now you've got another set of chains sitting there to look at. Kind of lengthens things. Kind of lengthens things. Man, my tongue is not working today. Anyways, so then we could talk about the seat pan itself. The seat is made up of a handful of bars welded together. Nothing really fancy there, nothing spectacular. Some of the seat pans themselves, where your butt sits, some of them are made up of like a fiberglass insert. It's like a smooth plastic looking insert that's sitting there. Others, like the Zamperla model I was used to working on, had a woven wire material in there. And I say wire material because it literally looked like you took wire, like, I don't know, probably about a 12 gauge wire, and just did a weave pattern all throughout this seat and all over the place. And you just made this wire weave, and it's like, that was the seat insert. Worked good for a while until they would break. I would much rather prefer having the fiberglass over those wires because we did a lot of seat replacement pans with those wires. That was a lot of work. And when those wires would break, you come up in the morning time inspection and you get a handful of them that look like they were just cut straight across just from the pressure sitting on top of them. That was like time to tag the seat out and replace it. There was just 4 screws on the bottom that held that insert in, so you just take them out and then grab a new one and put it back in. Typically wasn't a big deal. Underneath that, I know what the next people are going to ask, like, well, what happens if you fell through? It's like, no, typically underneath that pan, there's more metal bars underneath there. I mean, you could ride those seats with no pan insert on the inside, and you won't come out of the ride. Be fine. So those are more just for comfort than anything else. The last thing we'll talk about is the restraint itself. The restraint, very simple. It is a bar of metal that comes across. It's a round bar. It's about 20 millimeters in diameter. It's kind of, a lot of them get squished down to more of an oval. And then they have 2 really big rings on the outside. And the rings actually go down over the end of the seat. And I'm not sure if they planned this or if it was just a happy accident, but it looks more planned than anything. As the ring comes down on the seat, where the chain's attached, the fixture is shaped kind of like an upside down L. And what happens is as you bring this thing down, you have to actually take that round ring and go backwards and then forwards, and then it sits down flat. Well, actually, what that does is when it sits down flat like that, is that with it being unbuckled, you could just try to like lift it straight up and it won't lift straight up. You actually have to sit there and carefully, like a game, twist it to go back forward and then up on the front end and then out. And you can't just do that on one side, you have to do both. So it's kind of like a little puzzle. You have to get, most people figure it out really quick. Just go and then you can lift it up to get out. But it kind of doubles as pinning the restraint back down in there. Now those are held shut by a simple spring latch on there. By spring latch, I mean you see them all over the place. It's like a bungee cord end. You just push on it, the little gate opens up. Let's see, it look like this. And when you push on it, the gate opens up like that, and then it simply just springs back into place. Like that type of latch is all they use. They're not monitored. Even on Zamperla's website, it says it right there, restraints, they're not monitored. It's simply for people to look at, like they go around and check and make sure everyone's seatbelt is on. Yes? Is it clipped in? Yes. It's like, okay, start the ride, and then you just pay attention to people as they're going around. You pay attention to people like the operator was doing for that ride accident. They were paying attention because they were saying, hey, stop it, stop it. The kid's obviously sitting there fiddling with the restraint, sitting like, oh, I wonder if it'll come undone. I wonder if it'll come undone, and probably undoes it and probably opens the restraint. And then the operator's like, that's when the operator's like, has to stop the ride. We're getting there. Hang on. Oh, if you haven't by now, make sure you like and subscribe. Do that stuff. I make these videos. I try to make them once a week. It's been challenging for me because honestly, before about a year ago, I was making them like once a quarter, and then after about a year ago, after the Fury crack, started making them once a week, and I've been on that pace ever since. But it gets challenging for me to keep up this pace because this is not my full-time job doing this stuff. I just do this for fun. But yeah, make sure you like and subscribe. Let me know if there's something you want to see out there. I might already have a video. A lot of people say, hey, you should make a video about this. And I'm like, I already have one. Here, check it out. But that sort of stuff helps when you like and subscribe and share all that stuff downstairs. All right, so let's talk about operation. So there are two modes. There's an automatic and a manual mode. The manual mode is really only used to warm stuff up. So you could typically run the inner motor and you could run the outer motor. The inner motor or lower motor spins the tree. The outer motor spins the canopy. Okay? And we'll get into that stuff. And they typically spin them at what's called a service speed. It's much slower. It's very slow type of speed. So when we talk about the overall speed of the ride, the maximum RPM of the ride for a Zamperla flying carousel is 11 RPM. It's listed right on their website. The maximum RPM is 11. That is not the RPM that the ride is actually turning, though. The canopy, how fast that canopy spins with all the seats attached to it, is actually spinning internally at 17 RPM. How is that possible when the maximum RPM of the ride is 11? Well, the internal RPM, the tree, remember I said the tree spins as well? The tree spins at 6 RPM the opposite direction. So if you think about it on top, the big canopy, it turns clockwise like this. It's just turning around this way. Well, the tree turns counterclockwise. It's turning this way. So they're turning opposite of each other. And what happens is that your overall perceived RPM that you could actually stand there and watch, which we would do all the time when we were adjusting speed. We'd sit there with a stopwatch and we count the RPM, all the revolutions in 1 minute, and make sure it wasn't over 11. But that perceived RPM is actually the 17 RPM the canopy is doing because the tree is taking away 6 RPM. So your total RPM is your canopy minus the tree. That's your output RPM that's actually at the swings as the guests fling around there. So because of that, you can't get too far away from the lower, because if you get too far away from the lower RPM, your upper RPM, that means it's going too fast. So the speed safeties on these, they have a maximum RPM limit that says you have to turn this much or can only turn this much to go. But the safety is actually making sure that the two RPMs agree with each other within a certain ratio all the way, all the time. So what happens is that let's start the ride up. Okay, when you hit start, the inside and the outside both get the command to ramp up to like their service speed. So it's like, okay, it's a slower speed. So they both ramp up. The internal ramps up to 3. The external ramps up to 6. That's 3 perceived RPM on the outside, because 6 minus 3 is 3. So that's 3 perceived RPM on the outside. So that canopy is turning 3 RPM. But what happens is that the ride is watching through these little custom sensors, these little custom modules that they made. It's watching the upper pulses and the lower pulses. And what happens is when they get out of sync with each other, the ride starts a timer. And if they're out of sync for too long, the timer drops out and shuts the ride down, because it's like something happened. The upper didn't speed up enough, the lower sped up too much. Something in those two drives disagreed with each other and they faulted out. And it's like, okay, there is a speed disagreement. So that's how the safety system works. And it does that at multiple speeds. And there's different relays for watching those other speeds as well. So the system is very finely tuned in those areas. So it starts up and it goes to those service speeds. And it goes 3 and 6. So it gives our 3 perceived on the outside. At that point, the canopy starts lifting as well. Now, the safety in this is that below a certain distance off the ground, the canopy can't speed up, because if you kept it on the ground and sent the canopy into its full speed, the swings would come out like they normally do. Well, the swing diameter is larger than the perimeter of the ride. Does that make sense? So let's say when you construct a ride fence around this thing, you put the fence in a 30-foot diameter circle. And then when you start the swings up and spin them up to full speed, the swings produce a 40-foot diameter circle. So there's 5 feet on each side, which would be interference, which is where you're hitting. You can't do that. So as part of the safety, they say we have to get the canopy up past this certain level, and that's where those limit switches on the tree come into place. About 5-6 feet up the tree, there's a limit switch, and there's actually 2 of them there. When it passes those limit switches on the center of the tree, when it passes those limit switches, that is the safety signal that says, okay, both of you, upper and lower drive, both of your drives go to work speed. Work speed is what the final speed, it's the fast speed. So both drives go to work speed now. And work speed goes okay, and then they both start to ramp up. Typically those relays will drop out, and that fault logic starts to pop in, because the relays will say, I'm disagreeing, I'm too low, and the other one says I'm too high, and then they start popping in and out with each other as the drives accelerate, due to the dynamic loading of the people in the seats. Whether they're all sitting on one side, or you got little kids sitting over there, the heavy kids sitting over there, all just depends on what's going on. And then eventually it makes it up to its max RPM, 17 on the canopy, 6 on the tree, which gives you your 11 perceived RPM on the outside. So that's what it's doing the entire time. When it's up there, as it goes up, it reaches another limit switch at the very top and tells the hydraulics to stop. It says, okay, kill the hydraulics, and the hydraulics just simply stop. And the canopy sits there. Now, a lot of people may be asking, like, oh, the canopy is like doing this undulation, this wave motion. Like, how does that do that? It's really simple, actually. The canopy goes up and down the tree. The tree is simply just bent at the top. That's all it is there's just a bend in it, just like that. So the canopy spinning circularly around, like say where my hand is, it goes up, and then once it goes up to that top piece, it bends. Well, how come it's not just spinning in this angle right now, just elliptical? Well, it's not going that way because the tree is spinning at the same time. So if you think about it, you're holding the canopy in this motion because the tree is like this. And then as I start to rotate the tree, the entire tree goes around like this on the inside. So as that tree is going around, your canopy goes around as well, like that. So the tree rotating with the bend in it is what gives the canopy that undulation that does essentially this. If you were to shut down the swings and stop the upper canopy from spinning, you'll just see it sit there and rotate like this. Doesn't look very fun, but then you spin that canopy up to its max RPM and get the swings moving out to the sides, and that's what gives you that really fun swinger movement as it goes around. Quite fun. I enjoy it. It's always one of my favorite rides to go get on. One of my favorite things to do is ride those rides backwards. One thing you can't really do as a guest, don't try it. It'll kick you out of the park for doing it. But maintenance, yeah, I ride that thing backwards. Very fun doing that. No, we don't spin it backwards. This is where you turn your seat around backwards and ride it from there. People who know. I can't explain it here. Okay, so at the end of that, we're done with the cycle. What signals the end of the cycle? Well, in the control panel, there is simply just a ride timer there. For a lot of flat rides, the ride timer is actually on the control panel. It's not inside, it's on it. The operator can adjust it. It is one of those things. During days when the park is running slow and there's hardly anybody there, the operator can turn it up in time. On days when the park is really crowded and they're just trying to get people through there so that everyone's not just complaining about how hot it is in line, they'll turn the timer down. So on a really busy day, your cycle might be 1 minute start to finish. On a slow day, your cycle might be 2 minutes start to finish. But that is the purpose of the ride timer. We actually dummied our ride timers in on pretty much all the flat rides because we wanted the operators not to mess with it. We let the supervisors say this is how long we want the cycle. We set it there, but the ride timer was actually out of the control of the ride operator. There was a timer on the panel, just didn't do anything. The actual timer was in the back. That's where we adjusted the time, was back there. But we also worked with the operational supervisors. If they said, hey, we want to turn that down, rare they ever did it, but if they wanted us to turn it down, we would go easily just go in there and go, okay, yeah, there you go. Watch a cycle, make sure it was still in the time frame that they wanted, and then go, yep, okay, that's good. But anyways, a ride cycle signals the end of the timer, and it says, okay, time to shut down. The shutdown of a wave swinger is the hard part. Everything up until now was easy. The shutdown's the hard part because you have all this mass that's swung way out to the edges and everyone's flung way out like that. Well, now you have to stop them. Well, what happens if you stop something like that? Can you just grab a hold of it and stop it? No. Why? Because of wrap. W-R-A-P. Because of the wrap. If you stop that in the center, all the swings will go right around to the center and just crunch right in the center. Everyone will slam into the center because all those swings had all that momentum. You stopped the canopy. They continued in their trajectory, but they couldn't, so they were just pinned and went bing right into the center of the canopy. So everyone gets hurt. You can't do that. So what you have to very carefully do, and this is a lot of fine-tune adjusting on drives and stuff like that, what you have to do is you have to say, okay, we're going to go from our 6 and 17 RPM back to our 3 and 6 RPM. But we're going to give you a long time to do it. And we're going to go in there and adjust and make sure that when the drives go into their slowdown mode, I'm going to take a lot of current away from the drive. What does it do when you take current away from the drive? When you limit the DC motor's current, it's not forceful. It can't say, stop. I'm going to stop the RPM now. It can't do that. You could say, hey, stop right now. And it's just like, yeah, I'm going to try, but it's not going to work that well. So what you have to do is you have to slowly and carefully bring that canopy RPM back down to those 3 overall RPM. That has to be done evenly because it has to be to that lower safe speed by the time it hits that low tree or that mid tree limit switch. Because if the canopy is still going too fast when it hits that mid limit switch halfway down the tree, the whole ride shuts off, goes into e-stop mode, and everything locks up because it said I was trying to come down. Remember how unsafe it was to have the swings out at fuller speeds. So the ride says I was trying to come down, and then when I got to my safety check, I said, what's my speed? And my ride said, it's too fast. So I went, oh crap, shut it off. So we killed everything. We locked it up right where it sat. And then even the e-stop functions on those are tamed down due to the brakes on those. There's a lot in the braking mechanism, and I'll go over that in just a minute. So now we're at that 3 RPM mid-limit switch, and we continue to do that, and we continue to bring it all the way down until it stops back down on the ground, and we kill the hydraulic power and tell it to stop lowering, which is also, there's a mechanical stop, so it can't over lower and like drive everybody down on the ground. So it hits a mechanical stop, and the hydraulics stop there, and then at the same time the drives go from that overall 3 RPM to overall 0, more on the quicker side. And then once the drives all reach 0 speed, the canopy is stopped. It kills all the power to the drives and applies the brakes on both motors, upper and lower. Now, the brake on these motors is part of the safety process. The Zierer models have to be torn down annually. From my understanding, again, I have not worked on one of these specifically, but I've talked with people that have done that, and I've talked with inspectors with those Zierer models, and they say they are prone to cracking in the tree. That tree structure that goes up there's prone to cracking. All that stress in that canopy of accelerating and slowing down every single cycle goes into the tree. You think about it, if you sit there with your arms and you sit there and you go back and forward like this, accelerating and deaccelerating a lot, what happens? You would get really good ab muscles because your body's consistently doing that. So it's got to build those up because it's like, I need to be stronger. Steel doesn't work that way. You make it thick so it's able to handle that torque. And then after a long time of doing that, maybe too much, it becomes fatigued and then it starts to crack. So that's no good. We don't want cracking in things. So they have to be very careful with those rides not to put too much stress into the center tree. One of the safety designs is the brake on that lower and the upper motor. The brakes for those motors, the disc on the inside is like, they're like that big. They're like 3.5 inches in diameter. The actual grip friction material that's on there is only about a 1/2 inch wide. They're super small. Most of the time standing there, if you just grab a swing and start to pull the canopy backwards, the canopy will rotate backwards because you're overcoming that brake. So the brake is just meant to help slow it down and hold it. Realistically, that is one of those rides where that brake is simply just a holding brake. But in the event of emergency, like going too fast, those brakes will apply and they will take speed out of the canopy so that the canopy can slow down faster than it would just under no brake at all. So the brake is a very big part to the safety of the ride. Let's talk about evacuations. How do we get people off of a wave swinger? Well, in the back, there is a hydraulic valve That's a bypass valve. You go back to the back power unit and you simply just open the bypass valve, and that starts letting pressure out of the hydraulic cylinders, and the cylinders start to come down. We had talked about for a long time trying to add in an automatic bypass. Something, if we said, okay, if we hit the e-stop and we were able to, like, we shut everything off, we just wanted the canopy to slowly come back down. It didn't have to be fast. It didn't have to be quick. We just wanted it to naturally bleed back down to nothing, so maintenance didn't have to show up to the ride. The people would be stuck on there for, like, let's say 2 minutes. And then after 2 minutes, it would have been down far enough to where people would be able to get off the ride. No one liked that idea. It was a bad idea. They said, nobody do that. Nobody do that. I wonder if some parks didn't install some sort of bypass override like that, because it kind of makes sense when you're looking at it during the heat of the battle. Kind of makes sense to put in an override like that just naturally lets the ride bleed back down to get people off of it in a more timely fashion. But it was a no-go for our park, so we never did that one. Now, whether it be an evacuation or simply just the ride cycle ending, we got in trouble for the ride ending too slow. That final 3 RPM as it was coming back down, we got it smaller than that, which the ride was okay with. We were still within our safety envelope. We got it slower than that, but our state inspector didn't like it because they said, you know what, you're going to confuse people and they're going to think that the ride is down before it's actually down, and you're going to get people hopping out of swings and possibly getting their shirt caught and getting stuck and getting some injuries. So the state actually wanted it to go faster during the descent process to ensure that people knew the ride was still running. Okay, it wasn't well defined in the manual, so we're like, okay, we didn't see a problem with that. We'll make it run a little bit faster. It was no big deal. Went back there. About 3 or 4 hours worth of tweaking on all the potentiometers on all the drives. It's like, okay, now it works the way it's supposed to. When it comes to letting the canopy back down, there is a really cool feature that's in the Zamperla models, which I haven't seen on anything else anywhere ever. On the hydraulic diagram, it shows it comes up to the ride, goes through the hydraulic coupler that allows rotation, and then it branches off and goes to each cylinder. Now it's not a double acting cylinder. It simply just pushes fluid in from one side to lift the canopy and then lets the fluid back out the same hose to lower the canopy. So Zamperla had thought about it, and they said, you know what happens if that slip coupler that's rotating just completely blows apart? It completely breaks. Does the whole thing just go bam down on to its lower stop? Does it just completely just hammer itself to pieces and injure everybody? Nope, it doesn't. I don't know if they built this or if it was pre-existing, but there's this really funky diagram, and on the hydraulic diagram it looks like a check valve. You typically have a seat with the ball that allows fluid this way, and then there's a spring pushing on the ball. So as the fluid comes in, pushes the ball back, and then when you try to push fluid backwards, the spring pushes the ball against the seat. It won't allow fluid back. That's how a check valve works. Well, this guy looks like a check valve, but it's got 2 seats, and the ball is in the center. So it's like, okay, so it'll allow fluid, but it wouldn't allow, because the ball would just roll to the other seat and check, and then go back and check on that side. Well, what they did is they put that ball in the center, they put a spring on both sides of the ball. So we had a ball in the center with a spring on both sides holding it in the center, with seats on both sides of that. And I contacted him when I was talking with him about a different issue. I was like, oh yeah, what is this? I'm like, what is this? It's right on the hydraulic cylinder itself. It's actually, the fittings don't go into the cylinder. They go into these 2 things that are on there. And they came back and said, those are called parachuting valves. Don't know if Zamperla made it. Don't know if they named it. Don't know any of that. They said, those are called parachuting valves. Purpose, please. And they said, if you had a catastrophic failure of a line, a slip coupler, anything like that, they said what happens is that the canopy tries to come down too fast, of course, and as soon as it does that, the flow of the hydraulic fluid, not the pressure, the flow of all that fluid suddenly rushing backwards, slams that ball into whichever way it's going. Really. So, yep. So you got the canopy full upright, and you could take a sledgehammer and completely knock the hydraulic line off the bottom of it. The canopy will come down, I don't know, probably let's say a foot. Canopy will go clunk and then just stop there. And essentially the canopy is locked in that position because it's being held hydraulically shut at that point. I was like, that is a really cool little thing. Again, don't know if they designed it. I don't know if it's used somewhere else. I've never seen it on any other hydraulic print so far ever. But I thought that was really cool. It's got a parachuting valve in it to prevent it from falling in the event that the hydraulic cylinder broke. Wow, that was amazing. So, with all that being said, I had to go into all that to say this. Okay, let's talk about the Waldameer Park incident out there. It's like, okay, so we know we had the kid trying to get out at full speed. Operator pressed, I'm guessing, E-stop. We don't have an official report here. I'm guessing operator sees a kid try to take their restraint off after the kid's been known to mess with it, and they're watching that kid. It's just like, okay, at some point I think they're going to hit E-stop. That's just my guess. It kind of makes the most sense. You know, you talk with operators, especially on the channel, operators are like, quick to hit E-stop. There's not much of a reason to hit stop, especially if someone's trying to get out of the ride. It's like, emergency, stop that thing. Okay, so they hit E-stop. The canopy came down. There's people saying that the motors are still going at full speed. So the tree switches aren't working, because remember, once we got down past the tree switches in the middle, it should have shut everything off. Well, if they hit the E-stop, it should have shut everything off. So what's going on there? So did all the switches up the tree fail? Not likely. It's possible. Motors are supposed to slow the canopy, though. It's not like your E-stop is supposed to slow the canopy. The motors are supposed to slow the canopy. So did it happen without the brake? I don't think it did. So I'm thinking this. I'm thinking that they hit the stop and the brakes didn't apply. But they didn't apply on one side. I think what happened was they hit the E-stop, and I think this is one of those parks I'm kind of wondering if they lock the canopy in place or just let it naturally bleed back down under E-stop conditions, kind of like I always wanted to, just let it bleed back down to the bottom. But if they hit stop and told the motion to stop and that lower brake locked up, it doesn't take much to stop that tree at 6 RPM. It's pretty easy for it to do. The canopy with all the weight is the one that's hard to stop. That's also the one where all the torque and torsion is up that center tree, where you don't want to just suddenly stop it because you'll crack everything apart going down the center. You have to slowly stop it. So the brake is very finicky there. Well, if you're always working with the ride and the brake isn't holding and the brake's not working, you might not find that out because the brake at that point is just a holding brake. So it might be one of those things where they said, okay, it was coming down, and they, let's just say E-stopped it. They E-stopped it, they hit it, the tree stopped, the canopy did not because the brake wasn't working. Since the brake wasn't working, the canopy was at full speed, the canopy has now suddenly sped up because the tree tried coming to a stop. The canopy is now just trying to match its original 17 RPM that now the tree has taken out of it. So it's trying to it's actually would speed up if you suddenly took that lower RPM away. So the tree would actually, the canopy would accelerate from 11 to 17. But remember, it'd be loss of power, so it'd be losing a lot of speed at that point. But you'd probably notice it going from 11 to, I'm guessing you'd probably get it up to 12 or maybe even 13 RPM, although it'd be momentarily. But I'm still wondering about the bleed down action. Like, under an e-stop, why would the canopy continue to come down? Okay, so that kind of goes back to like, well, maybe they didn't e-stop it. Maybe they just hit ride stop. Okay, well, if they hit ride stop, then that should have sent both drives back into their slow speed or their service speed. And then the drives would have just slowed right down and then brought the canopy there as the thing deaccelerated. That doesn't make any sense either. So I'm really having a tough one with this one. It's like, how would this happen? So then to end it down there, the park said that they're replacing a part to fix the problem. So this is more in line with the upper motor brake not working. Because it's like, oh, what happened? Well, it sped up, it didn't stop. It's like, all right, because the motor brake didn't work. It's like, okay, well, we'll get a new disc. We don't have one in inventory. We'll get a new one. Maybe it's on a, red hot package coming from Italy. Maybe it's coming from a local supplier here in the US. That one, I'm not sure. But they're like, okay, we get that disc and we'll put that back in there. The brake will work properly. It'll be able to slow the canopy down next time. I still have the question as to how the canopy got down low while there was still rotation, but that is only coming from the background of the one I worked on would lock itself in the up position. Now, here's why I rely on other people, and I encourage people to please check the comments of the video to see what might be going on. For other people that have worked with or worked on these rides from different manufacturers, whatever it might be, did your rides come down even under e-stop? Like a bypass valve like I always wanted to put in mine. Like hit the e-stop and then the ride just slowly comes back down. The whole event lines up after that, right? They go through there, the person says, hey, keep your restraint on. The guy in the restraint's like, nope, I'm not going to do that. So they hit e-stop. At that point, because the brake wasn't working, the ride actually accelerated a bit, but was still continuing to come down. Maybe their bleed speed was a little fast. Still continuing to come down, and it comes down while it's still doing 11.5 RPM or even 11 RPM, 10 RPM even, and then it comes down into that below that 5-foot radius out there and then starts hitting things around it. Starts hitting, and then that's not an easy thing to stop. There's a lot of mass wrapped up in that canopy, so there would have been a lot of people hitting fences, posts, anything nearby. But that's kind of as near as I can tell what would happen. The other thing that you could have is that did someone in the park leave, let's say the thing wasn't designed to come back down. Did some mechanic leave the bypass valve open accidentally? I've had that before. We went through and had to get people off the ride, and then we fixed the problem, got the ride back up and running, and then like an hour later, more than an hour later probably, I got a call saying, hey, can you come down here and watch this? It seems like it's running strange. It's like, okay. So they unloaded it. We came down there. What's going on? And we watch it, and then while it was operating, like, the seats were doing their normal wave, their normal undulation, whatever you want to call it, as it was going around. And it was kind of doing this other thing inside there where it was like, it wasn't steady. It was like thumping for some reason. And I was like, that's odd. So we stopped it, brought it back down, and then I switched it into manual mode. And in manual mode, I simply just told the canopy to go up, turned the hydraulics on, and said just from the main operator panel, I'm just like, lift the canopy. And it went up, 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 up to the top, stopped. And I'm like, okay, I took my finger off the button. And then the canopy started coming back down. And I'm like, I didn't tell it to lower. Pushed it up again, up, 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 stop. I'm like, wait a minute. I'm not doing that. So I went back to the back room, and that was my first thought, was that valve. I went back to the back room, and that valve was still open. Since it was a small hose, because it's meant to not let the thing come down fast, what was happening is while it was going up there, that basket in the center was coming up the tree, and it would go up that curve and get to the top of the tree and stop. And then the hydraulics would shut off, and then it would come back off its limit switch, and the hydraulics would turn back on again. So on the tree, it was basically sitting there in fast motion. It was sitting there doing this number, going up and down, up and down, up and down, until the ride cycle ended. And then it just came back down. And because of the seats flung out and rotating and going through its undulation, look, nobody noticed for a good hour. And even watching it in full speed myself, I could tell something was kind of off, but only because the operators pointed it out. And I'm like, hey, something's off, but I wasn't sure what was off. So I'm wondering if maybe the bypass valve was left open and they had a brake go bad. Well, the brake was bad for a long time, but just it manifested itself in that fashion for that one. All right. I know this was a long video, but I wanted to do the reaction video, but I needed to tell you at the same time how a wave swinger works. I hope you guys enjoyed this one. I've actually had a lot of requests for this one. So if you have other requests for future videos, let me know. You could either just leave it in the comments. I try to make notes when people put stuff down that I'd really like to do. You could also send me an email at ryantheridermechanic@yahoo.com. That's an open text there. And if you made it this far through all my rambling, please subscribe. Think about it and watch some more videos. I've got tons of them out there, and each one's kind of like their own unique thing. I've had a person recently suggest, like, why don't you do more chapter guides to your videos? And it's like, I don't have that much consistent thought to make chapters, really. Yeah, people that have been to subscribed to my channel for a while, they're like, oh yeah, he's kind of everywhere all at the same time. You can never know what he's going to say during what point in time. It's one of the advantages of not reading any scripts at all. Okay, I think that's going to do it for this video. Make sure you like, subscribe, do all that stuff. And remember to stay off the air gates. Bye.